Okay, so our K is right here. Here. Looking at this first graph here, what are some things that we know? First, let's take up these two lines. What do we know about these two lines? What's that? They're parallel. Okay, how do we know that they're parallel? Right here. Little parallel marker here, parallel marker here. So, they're telling us that these two lines are parallel. Next, let's take a look at, well, what else do they give us here? They're giving us 4 points. So we have A, B, C, and then D. And D is the point that is missing its y coordinate, which is they. Okay. Whoa. Hold on. Let's take a look at this. Alex just said something that's key, so that these two lines are parallel, which means that their slopes are the same. So let's write that down here. F of AB B equals to F, okay, slope of C and D. Okay? Do we know what the slope of A and B is?
Yeah.
We do. How do we know that?
With their coordinates.
With their coordinates. Okay? A and B, right there. So what can we do with that? What can we do with A and B? So you see that we have the coordinates for A and B. What does that mean in terms of working with the slopes? Can we get slopes, the slope of a line, if we have 2 points?
Yeah.
Yes? All right, so how do we do that? All right, nice and loud for the microphone. Right, so y2 minus y1 so m a b equals 2 again. Keep in mind that m equals y2 minus 1 over x2 minus x1. So given that my points are y2 is -5, y1 is 5 over x2, which is 9, and x1, which is 1. What?
No, it was minus.
All right, follow me so far? Just taking our points A and B and plugging them into our m equals y2 minus y1 over x2 minus x1, okay, which gives us -10 over 8 equals -5 over 4.
Yeah.
Does that look okay so far?
Yeah.
Yes? All right, -5 over 4 is our slope. So, we know the slope of AB, right? We know that AB and CD are parallel, which means that the slope of AB and CD are the same. Now that we have our slope of AB, what can we do with that? That's what I meant, sorry. CD. For the record, the slope of AB is the same as CD. What can we do with that then if we have our slope of AB now?
Plug it in.
You plug it in. Plug it into what?
The equation of
The equation of
the slope.
a slope?
Yeah.
We have our equation of a slope right here.
Yeah, so M equals negative 5.
Okay, so let's just write this down for a second here. So MCD equals negative 5 over 4. Okay, so where should I go from there? Sub it into here.
Yeah.
Interesting. Okay. So we know that this is equal to, again, right here. All right, let's take some points here. So C, D. So we have our Y2 in our CD line is K. This 3. And it's 2 minus negative 4, so that equals 2 plus 4. Or positive. A minus 3 over 6. All right. Here I am. Let's clean that up with one more line. Or why don't I do this? All right. That's pretty cool. You're almost there. What can I do now? Does everyone see? Do you see where we need to go with this? If we're at this point here, can we now start to solve for K? We've determined our slope of CD because we know it's parallel to AB. Plugging that into our equation for a slope given 2 points right here. Plug those points in there. Our missing value is K. From this point on, it's inverse operations to figure out what K is. Someone come up here and do that for me? What's that? In terms of right here or the question in general? So you have a slope. Right now it's just, you're at a point where you're doing inverse operations to solve for k. Tell me what my next line should look like. What's my next step? This is chapter 4 stuff from this point on. Next line. Alright. Negative 5 over 4, okay, equals k minus 3 over 6. Do you guys like working with fractions as when you're trying to solve for a... Matthew's shaking his head. No? Michael?
You should multiply both sides by 6 together.
Both sides by 6. Okay, let's try that. That. Okay, we get rid of the 6 here. If I multiply this times 6, well, we know that this 3 here, 2 here. Or let me simplify that for something like this then. 6 times negative 5 is what? Negative 30?
You can break it down into 3, 30, 15, 15.
Right. It's a little bit cleaner in that we don't have the fraction on this side, but we have a fraction on this side still. By 2? Sure. All right. We're almost there. Chris, what do I do next? Add 6? Yes? Negative 9 over 2 is equal to negative 4.5. What does the book say? There you go.
Is that going to be on the test?
It's a really good question. I like that question. I don't know if it's going to be in the test, but that's a really good question because
I know.
if we're looking at this, it involves a lot of things. It involves being able to interpret your graph, okay, recognize the fact that we have parallel lines, okay, recognize the fact that when you have parallel lines, their slopes are the same. So that's a key point. That's a key theme of the chapter. Okay. Recognizing the fact that we have a formula for slope given 2 points, and being able to work with that calculation to come up with the slope and plug in some additional points with the same slope to solve for a value. So I like that question. If I were running a test, I would have a question. But I'm not writing this test. So I don't know if they would get the question. I don't know actually.
Just tell
No, I honestly don't know.
they will have like 7 hours.
So
Are you gonna post this on your website or?
what's that?
Are you gonna post?
Yeah, I'll post this on the. I'm recording it right now. So B. Okay, question for A. 15. Oh, right here. Okay, so what we want to do in this step here is get rid of our fractions. So Michael is saying, well, we have 6 here. Let's multiply both sides by 6 to get rid of the fraction on this side, which leaves us to work with this fraction right here. Okay. Because we have a 4 here, these would cancel out, so that's 2 and 3 because you reduce it. Or you can do 6 times negative 5, which is negative 30 divided by 4. So negative 30 over 4 would reduce to negative 15 over 2. There you go. What would have worked as well is this step, if you multiply both sides by 12, you'd be able to clean up the fractions in one step. In this case, we did it for 2. Well, that's just Do you want to take a look at B?
Yeah.
Enthusiasm. 20-minute question. Really good question. All right. Well, let's talk about it then. What are they telling us in B here? Perpendicular. Okay. So if our 2 lines are perpendicular, let's have here E and F and H and G. What would you do differently in this question here versus what we just did?
Get the slope.
Get the slope, flip it. So, okay, so that would mean you would follow the same process that we just did for question A, but when you get to this part right here, where you're determining the slope of one of your lines that you can do because that's what they give you, you would flip in this case here, but the numbers would be different for B. Okay, but when you get to this point here, you would flip the slope, and then you would work on the same process to come up with your value of K in question B. But it's key to know that on this step, this is where you flip it because it's dealing with perpendicular lines this time. So you could write that B you can write that the slope of EF is perpendicular to the slope of what's off the bottom? Perpendicular to the slope of HG. In this case here, you flip your slopes. I can work through this if you guys want me to, but it's basically the same stuff that you're going through here, except you're flipping back. Yes, yeah, closest. Good question. So let's say if this was my slope that I'm working with, I'm pretty sure it's going to be different in this case here. Maybe, maybe not actually, I don't know. But let's say, for instance, if this was a slope? Yeah, we're going to have to edit that part out. Alright. If this was our slope that we're dealing with in EF, right? What would our slope of HG be? Ooh, positive over 5. So let's see. That is negative 5 over 4 is perpendicular to. Do we agree with this? Yes? People on this side of the room, do we agree with this? Negative 5 over slope of negative 5 over 4 is perpendicular to slope of 5. Yes? Alright, so that's right. So we have a slope here, the negative reciprocal, so it's a reciprocal, we flip the numerator and denominator, and it's the opposite sign. So that's correct. So that's what you do for B. So if you're working with perpendiculars here, flipping the slope, and then continuing on as we did in part A. Negative 3 over 4 is the slope, somebody said. 8 minutes? Maybe. Alright. It's in positive. Alright. Period 2. I'm just letting it. Period 2. Period 2, question 2 from the review.
Period 2.
Now we're
Order each set of lines from closest to horizontal to closest to vertical. Right? Given A and A, B. Start with A. Alright, so what is this question telling us? What is it asking? That's the first step here, because a lot of people are confused as far as what the question is actually asking. Closest to horizontal to closest to vertical. But let's draw a nice line here for a second. Y, X. X, Y. All right. Closest to horizontal to closest to vertical. What is it telling? What is it asking us to do?
Oh, that's the question.
Brendan.
Which lines are like starting here and like which lines are like vertical?
Okay. That's right. So what it's asking us to do is order them in terms of, right, how starting from closest to horizontal, so which one's closest to We do it this way, just because you're
You have
using
to lie down.
Which one's closest to completely horizontal to more vertical, more vertical, more vertical? Okay? So order them in terms of steepness, if you want to call it. Write that on the graph here so you can see it on video. So if this is completely horizontal, right, which lines order them in terms of more horizontal to more vertical? That's what it's asking us to do. So given that, how can we determine that by looking at, let's take these three for a second. In question A, how can we determine how close things are to vertical and how close things are to horizontal by looking at our equations? So hands to back, hands to the front.
Yeah.
What? How can I tell by looking at these equations what piece of information will tell me how close things are to vertical? The y-intercept? Okay, why would the y-intercept tell us that? Y-intercept would tell us where on our vertical axis where lines are crossed, so it would tell us this piece of information. It would tell us that. Would that tell us how? So it would tell us where to start, essentially. Okay. So the y-intercept would tell us where to start. Okay. But what would tell us how close things are to vertical or horizontal is the slope information. Okay. The steepness is what would slope and how steep it is. Okay. Slope would tell us how steep a line is. That would tell us how close things are to vertical and horizontal. Okay. So in our equations here, what's the slope in my first equation? Y equals 2x minus 4. 2? Slope. Alright, good. Slope in this second one here.
One. Oh yeah, oh yeah. I knew that.
1. Okay. This one here? Moves everything. Alright. 1 over 3.
Oh, okay.
1 over 3. There you go. So, that's what we need for slope. So, if we have a slope of, well, let's see, m of 1 is, slope 1 is 2, slope number 2 is 1, and slope number 3 is 1 over 3. Okay, which one is most horizontal? Most horizontal.
How would you figure it out?
Well, you could, how would you know?
What lesson was this one from?
5.1, I believe. Yes.
First one.
First one, right off the bat. Remember when we were filling out that chart and I had you guys fill in, draw sample slopes and sample equations for things that were steep and rising to the right and 45 degrees and gently rising? Okay. What properties we'll be able to, I guess, determine from that. If a slope is steep, what does its slope number look like? What would it be?
Small.
Smaller?
No, higher.
Higher? Thank you. So keep in mind that slope is rise over run. So
But what's considered big?
it's all relative. Rise over run.
Yeah.
Oh yeah, wrong.
Rise over Captain.
There you go. Slope is equal to rise over run. So if my slope value, right, which one of these is the highest?
2.
Thank you. Yes, we got it.
Yes. Does that mean it's
Slope is the highest, right? Number 2.
Yeah.
Okay, which means that this is also equal to what? In rise over run. If you were to express this in terms of rise over run, what would that be?
2 over 1.
Thank you. So it's equal to 2 over 1.
So the run is 1 and the rise is 2.
Right. So and this one here is what?
1 over 1.
1 over 1. This one here is
1 over 3.
all right.
That one's kind of straightforward.
Yeah. All right. So if we look at our rise over run, our rise on this one is the highest, right? Rise of 2 over 1. This one only goes up 1 and over 1. This one goes up 1 and across 3. So if we were to actually,
Will you redraw that?
draw that out,
You have to draw it out as you get marks.
if it asks you to draw it out, then draw it out. Or if it asks you to justify something and you feel that dropping it out will help you justify something. All right, so if we do, well, let's start with the middle one. 1 over 1. What's 1 over 1 look like?
1 up.
1 up, 1 over. So that would look something roughly like, let's go black. Looks something like this.
Yes.
45 degrees.
Oh, you have to press those button things and then
I can do it. All right, so this one here is m is equal to 1, okay? Because it's going as it goes up 1.
that one's interesting and it's available.
Up 1 and over 1, okay? If I do 2, that's going to tell me, well, I need to go up 2 and over 1. So that would be like point right there. Let's do that in 3. Up 2, up 2, over 1. So something like that.
That's very strange.
Is 2. And then this one here, it's saying, well, we go up 1 and then over 3.
How does n
What?
Where?
That's the slope, man.
This one here?
No. The equation.
That's my equation.
That's slopes.
why is it N1 and T?
Oh, because I'm just saying this is equation 1, equation 2.
Oh.
It's alright, to clarify. This one here, I'm going up 1, and then over 3. Up 1, 1, 2, 3. Okay, so I know that there you go. So in terms of which one is closest to horizontal, 1 over 3 is closest to horizontal. This horizontal is right here. This one is closest to it. M equals 1, and then closest to vertical is
I want 1 over
M equals 2.
It's even.
1 over 1. This is 1 over over here.
Yeah, but it's even.
But in terms of which one's, it's closer to vertical than this one is.
No, I know. I'm saying though, if you had to say if M2 is vertical or horizontal, what would you say?
Well, I wouldn't ask whether or not it's vertical or horizontal because it's neither. It's in between somewhere. So what it's asking for is which one's closer to being vertical. So that's the order of it right here. So if we were to put a number on that, that would be closest to horizontal is this one, followed by this one, and then most vertical. All right, let's look at B then. And trickiness.
What's it?
All the name.
Well, it goes on the opposite side.
Closest to horizontal, closest to vertical. Without graphing this, without doing this visually, can we look at our numbers here and figure out what the
Yes.
order is?
Yes.
Okay, Joseph, how?
Okay, because the first one, since it's negative, you know that it's gonna go to the left down one. Right?
Okay.
And then the next one is minus x, so it's minus 8 over minus 1. So would that become 8 over 1?
Let's write this down, make sure that we're all clear. So for this one here, our slope is equal to what? Minus 1 over 3. Okay. This one here is what?
Minus 8 over 1.
Minus 8 over 1. This one here is minus 5 over 2. Okay. Thinking about this in rise over 1, what does this one do?
It's going down 1.
Down 1 and
Left.
left 3?
No, right 3.
Right 3. Okay? Because you're going, you will let your sign, okay, in your slope. It's good to go with the practice of your sign determining whether or not you go up or down. Okay? So let your sign stick with the rise part, control that, up or down, and then have your run go across to the right. Okay? It would still work if you use your sign on the run, you can still come up with the same line, but just in terms of, to eliminate the confusion, stick with, when I have a negative here, that's going to tell me I'm going down. Okay? And my run is always going to be across to the right. So if I'm looking at this one here, what's it doing? Negative slope of negative 1 over 3, what's it doing? Worse? Okay. Tell me when you think it's going the way you want it. Ready? No?
Stop.
No? Okay. Horizontal?
No, it's closer to horizontal.
Looks like
Like that.
like that?
Yeah.
Yeah? Negative 1 over 3? Okay. It's not the most precise graph right here with my arm, but you get the point in terms of if you're looking at it here, you get a feeling of whether or not it's steeply falling. Because if you look at our negative numbers here, all these are falling. They're all going down and across. So they're all going to be from in this range right here, like this. Okay? But it's a matter of how much it's going down is what we're looking at here. -1, so that's sort of going down, and it's going across 3. Okay. -8 is going way steep and only over 1, so that's pretty steep there. Okay. What about these two here? Which one's steeper? -5/2 or -1/3?
Wait, steeper, does that mean more vertical?
Yes.
Okay, so then it's -5/2.
-5/2. Why?
Because the rise is bigger than that, and also the run is smaller, which means the run will be farther, so it's going to be closer.
Okay.
Vertical.
So I like the way you put that. So our rise is higher in that it goes down more than this one, and it goes across or runs less than this one. So it's certainly more vertical than this one is over here. Keep in mind, what you want to keep in mind is that the closer the number is to 0, it's going to be more horizontal. Whether or not it's negative or positive. The closer it is to 0, it's going to be more horizontal. The further and further away the slope gets from 0, it's going to get more vertical. So if you were to just do the divisions on these, you would get something like -0.33 as a slope. This one is just -8. And then this one here is -2.5. This number right here, -0.33, that's closest to 0. You guys see that, right? This one's pretty far, and this one is in between the two. In terms of how close it is to 0. So that is your indicator as far as which ones are steeper than the other.
So the most horizontal is the first one,
Yes.
and the most vertical is the second.
Yes.
But the third one's still a little vertical, right?
Third one is vertical, but not as much as the middle one. All right, so number 4 is asking us to determine the slope and y-intercept for each of these lines. Let's take a look at A. X minus 4y 9 equals 0. This equation is in what form?
AX plus BX plus CX equals
That's what you were saying. AX plus BY plus C equals 0, which is otherwise known as wrong.
No, I was talking about something else.
Okay. Otherwise known as standard form. If it's asking me to determine slope and y-intercept, what form should I be in? Y equals mx plus b. Why? Right. All right. So again, what Joseph is saying is that if we go into change that into y equals mx plus b form, that will give us what we need in terms of determining our slope and our y-intercept. So what do I need in order to get from standard to slope-intercept form, y equals mx plus b? What do I need to do with our equation here? Move it over?
Yeah.
Okay, alright. Otherwise known as
Isolation.
isolation. Okay, what do we isolate?
Why?
Yes? Isolate the y? Yeah? We're good with that?
You always isolate the y.
Alright. Isolate the y. So, Melissa, you were saying, what's my first step should I do for isolating? Okay, let's do that. What I'll do. Hold on. We're working on a question.
Which one we isolate? Why?
Alright. My next should be 9. Alright, almost there. Bring it home. Alright. Which gives us y is equal to y is equal to what? What's my 3 over 4? Okay. X.
Yes.
Alright, what's 3 over 4? What's the rest of it?
My hand is up. My hand is up. Should I stand up?
Think of other people. Suppose that your hands up. Plus 9 over 4. It's a plus. 3's right here. Negative 9 divided by negative 4, which gives us plus 9 over 4. Dang. Alright, so do we have what we need to figure out slope and y-intercept?
Yes.
Alright, what's our slope?
3 over 4. Can I do the 3 dots?
Y-intercept is
25 to
9 over 4.
Can you make it a fraction? I mean, on the decimal. If it's an even number, can you make it
What's 9 divided by
2.25?
1.25? 2.25? Alright. So again, anytime you You have the equation that's in standard form, ax plus by plus c equals 0, or this case here. Oh, there it is. And this one right here, that's in what format?
It doesn't matter if it's B or C.
Not really. As long as you can tell the difference between the D. This one. What's that? These two? C is in this one. And D is in this one. B is in this one. Okay. So anytime you're in an equation of one of these two forms, inverse operations to get us to y equals mx plus b format, and from there should be able to determine your slope and your y-intercept once you get into the y equals mx plus b format. Good? It's going to be a long video. We're at 52 minutes for this video. Yes. I don't even know how it's going to upload it. It's going to yell back. Okay, so we are in ax plus by equals d format with this equation here. Want to get it into slope-intercept format, y equals mx plus b. So we want to isolate our y. Again, so let's go with, well, let me rewrite it. 32. One over 3? That one. Yeah. 32 over 6 give me what?
16 over 3.
16 over 3. Yeah. It's an ugly fraction, right? Minus
Are we gonna do all this question?
negative 2 over 6, which is... Oh, hold on.
Negative 1 over 3.
Alright, so right now you're actually in the right format, but it'll probably be just to sort of clean it up so that you're in match this format here. You can switch around your operations. Yeah, so basically I just took 32 divided by 6 and I reduced it. Okay, and then negative 2 divided by 6.
You have to simplify 16 over 3, like next to
I don't think so. Does the textbook want you to? This is, if you were to say here, then our slope is